Pearson's chi-square test and Fisher's exact test. This is the outline that we will go through by several videos. Let's start with Pearson's chi-square test. Introduction. As in most cases, Pearson's chi-square test is best explained using a practical examples. Suppose we want to investigate whether a new vaccine effectively prevents influenza. To study this, we conduct a triple-blind, randomized controlled trial. The investigators, clinicians, and analysts remain blinded throughout the study. A total of 400 participants met the inclusion criteria and were randomized into two groups. 100 participants received a placebo. 300 participants received the vaccine. At the end of the study, 50 out of 400 participants contracted influenza. An overall probability of influenza is 50 divided by 400 equal to 0.125. Because the study was blinded, it's unknown how many cases of influenza occurred in the placebo group and how many cases of influenza occurred in the vaccine group. That's why 4 question mark. Here are questions. What is the probability of influenza in the placebo group? What is the probability of influenza in the vaccine group? If there's no difference between the group, if the vaccine did not prevent influenza, if the two groups were independent. In this presentation, the above 3 statements convey the same meaning, therefore will be used interchangeably. Most often, we will use the third one. Let's continue. If the two groups were independent, probability of influenza in the placebo group equal to the overall probability, 0.125. Probability of influenza in the vaccine group equal to the overall probability, 0.125. Expected numbers if the two groups were independent. As we know, overall probability of influenza equal to 50 divided by 400 equal to 0.125. If the two groups were independent, probability of influenza in the placebo group equal to the overall probability, 0.125. Probability of influenza in the vaccine group also equal to the overall probability, 0.125. Here's the question. What is the expected numbers if two groups were independent? Concretely, what are the expected number of influenza cases and non-cases in the placebo group? What are the expected number of influenza cases and non-cases in the vaccine group? The following table demonstrates how to calculate the expected numbers. As we know, probability of influenza in both groups are 0.125. Therefore, the expected number of influenza cases in the placebo group is 100 multiply 0.125 equal to 12.5. Although participants could not be fractional, we will keep this value for precision in calculations. The expected number of influenza non-case in the placebo group is 100 minus 12.5 equal to 87.5. The expected number for influenza cases in the vaccine group is 300 multiply 0.125 equal to 37.5. The expected number of influenza non-cases in the vaccine group is equal to 300 minus 37.5 equal to 262.5. The expected number of influenza cases and non-cases in both groups are summarized in the second table. Mathematics underlying Pearson's chi-square test. The key point Pearson chi-square is to compare the observed numbers with the expected numbers. The first table is the expected numbers that we calculate before. The second table is the observed numbers when the label were opened. Pearson's chi-square compares the observed numbers with the expected numbers. Concretely, for example, for the first cell, we subtract the expected number from the observed number and square the difference, and then divide this by the expected numbers. We will repeat this for each cell, the second cell, third cell, fourth cell. Finally, we sum these values across all cells to compute the chi-square statistic, roughly equal to 6.8571. Degree of freedom in chi-square test is the number of rows minus 1 multiply number of columns minus 1 equal to 1 in this particular example. Based on chi-square statistic and degrees of freedom, we can find a p-value roughly equal to 0.00829 or roughly equal to 0.009. These slides illustrate what is the mathematics underlying Pearson's chi-square test. Conclusions based on Pearson's chi-square test. Non-hypothesis, two groups are independent. Alternative hypothesis, two groups are dependent. Based on chi-square statistics and degrees of freedom, the p-value roughly equal to 0.09. Because p-value is smaller than 0.05, which is significant at 0.05 level. Therefore, we reject the non-hypothesis and accept the alternative hypothesis. This is the end of this video. We will continue next one. See you.